This again is the 310 to 311 review. Calculators still are not allowed, and this is number 3. Again, with this problem, we do not get an instantaneous snapshot. Instead, we are asking to analyze the relationship between the rates. So if we read this, it says the width W of a rectangle is increasing at a rate of 2 inches per minute. So that means that dW dt is a positive 2. This is something that we know. And it says the length is decreasing at a rate of 2 inches per minute. So that means dL dt is a negative 2. And the question is, what must be true about the area of the rectangle? So that means we probably want information about the rate at which the area is changing. So our goal is to get a relationship between the area, the length, and the width when the shape is a rectangle. So we could draw our picture in step 1 with the length and the width. And then we can write an equation where the area is the length times the width. Then we can go to step 3, which is to take the derivative with respect to time of both sides. And where people will mess up on this is they will neglect the product rule when they're taking the derivative of the right side. So if I take the derivative, I'll get dA dt on the left, and on the right I will get the first one times the derivative of the second plus the second times the derivative of the first. So now if I plug in what I know, there is no step 4, but I can plug in my dW dt, which is positive 2, and my dL dt, which is negative 2. And then I can write dA dt as 2 times, oops, that's a W, and L minus a W. Now, looking at this, I have several things that could happen with this dA dt. I could have dA dt be positive, and that's going to happen when this L is larger than this W, because then L minus W would give me a positive number, and a positive times a positive will give me a positive. So this will happen whenever L is greater than W. And if dA dt is positive, that means A will be increasing. If its rate of change is positive, then A will be getting larger. We could also have dA dt equaling 0. That's going to happen when L equals W, or when A is constant. My final option is that dA dt could be less than 0, and that will happen when I subtract more than I start with. So that's when W is greater than L. And in that case, A, sorry, ran out of room, A will be decreasing. So this will probably be a multiple choice problem, which means you're going to be looking for when A is increasing or constant or decreasing, and what conditions on L and W will provide that outcome.